To satisfy the state of South Carolina, you are going to use a free body diagram to represent the gravitational and electrical forces on a charged object. When I read that standard, I immediately thought about Millikan's oil drop experiment. Robert Millikan was a scientist, and he did something amazing. He was able to experimentally determine the mass of an electron. The mass of an electron it's so small, it's unfathomable how small it is. And how he could do that in a laboratory it just blew my mind. But it's actually pretty eloquent. And I think I can demonstrate what he did in the laboratory quite simply for you right now. Charged particles inside an electric field. It's a pretty big charge. Smaller charge. Whoop. Think about that for a minute. Why was it suspended? Why was it suspended?
Because the inflator thing was blowing up on it, and then the gravity pulls it back down when the force of the wind isn't strong enough anymore. And
So you had a mass,
goes back.
and you had a force of gravity acting on it. And then there was a force of, I don't know what you want to call it, wind. The force of wind blowing it up. And when those were in balance, it kind of hovered. If the weight of it brought it too close to the wind was stronger. I don't know whether it's obeying an inverse square law or not, but in any effect, when it got closer to the source of the wind, it blew up until its weight force was greater, and then it came back down and it found some sort of balance. This is how Millikan determined the mass of an electron. He got a charged object in between two plates, and he adjusted the voltage until the oil drop floated. Okay, to wrap this up, I've taught you everything that you need to know in order to calculate the forces on an oil drop suspended in Robert Millikan's apparatus. So that's what I'd like for you to do for homework, and I look forward to seeing what you can do.